In this lab work, we are doing georeferencing for a topographic map and also for an aerial photo based on the georeferenced topographic map. Then we will create a new vector layer. Third is extract geometric parameters like area and perimeter from the created vector layer. And finally, change the vector layer to feature point. Let's find the folder. My folder is this one. Extracted. Here is the extracted folder. Let's open ArcMap. It might take some time. You will have a catalog here. The first thing we need to do is connect the folder. Here we can see connect to folder. I have placed my folder at this drive. So this is my lab work. I want to connect this folder. Okay. So here we get our folder. We can expand it. And this is the file we want to work first. We can drag and bring it here. Okay. There's another way of bringing the file. Let's remove it. What you can do is we can go to add data. We can find our designated folder. See, it is here in the folder connection. We can also connect folder from here. We can go to our desired folder, go, select it and add. We are working on data view. This is layout view. Now let's bring the next file. Let's select it, drag it and bring it here. Okay. These are the check and uncheck. Let's uncheck it because we will be first working on the top map. Now go to the layers, right click, properties, go to general. Here at the map, you see degree decimal and display degree decimal. Change both of these into meters. Change the coordinate system. 1954, search it, hit enter. The one that we need now is Beijing 1954-3 degree GKCM 120 East. I will add this to favorites because I will need it again. Now select this, apply, and OK. Now we are about to georeference this global map. So let's make sure that we have selected the right file here. As you can see, this map has x-axis and y-axis, longitude and latitude. We need to know which latitude and which longitude we are using for our georeferencing. In this case, I would like to choose 4 points in the corners and 1 around the middle. So beginning with this point, let's see what it is. Okay, let's go with this line. So it's 388. When it goes east, it's 389. And the further east it goes, it's 390. Similarly, this line is, this point is 3553. When it goes down towards the equator, it's 3552, 3551, and so on. So for this point, our x should be 389 and the y should be 3551. Now let's zoom in to this intersection. So here we find the intersection. Now let's go to add control points. Right click and then we can input x and y. So the value of x, as we have known, is 389, and in this case we have to put 3 zeros in the end because we are working in meters and not in kilometers. For the y-axis, it's 3551, and we need to add 3 zeros, 1, 2, 3. So we got our first control point, and if we can see it in the table as well. Zoom to layer. Here is our first control point. Our second control point will be somewhere around here, And as we know, the y-axis is already 351. To check the x-axis, we have to see it. So it's 3548. Three eight nine 1 2 3 3548 1 2 3. Now the third point. Let's check the x-axis. So it's 393. Right click, input XY, 393, 3548. Okay, let's go for this point. Click, right click, 393 and 3551. Let's get some layers. So we've got our 4 points. Now I will take the last point somewhere in the middle. And let's check its x-axis. It's 91. So that's 391. And the y-axis is 3550. 391, 3550. In this way, we have got our 5 control points and we have georeferenced them. Let's check the table. So in this table, we can see the residual x and residual y, and we can check the total RMS error. So it's 1.5, not very bad. It's considerable. After doing this, we'll go here and then we'll update the display. After updating the display, we need to save it. So go here and rectify. To rectify, we can choose our output location. So in this case, I will go to the lab folder, and inside that folder, I will create a new folder to name it output. Add folder, and I'll give a new name to the Georeferencing one. It's Georeferencing one rectified. Now I'll save it. Okay, the file has been saved. Now we don't need it anymore because we have got the rectified file. We have saved it. So let's go to the catalog. So what we need to do is we had created a new folder within this folder. We need to right click and then refresh it. Now we can see the output. This is our file. Select it, drag and bring it in. So this is our file, but we cannot see the picture clearly. Right click it, go to properties. And here in the type, we have to get the standard deviation. Now we don't need this one. We can just remove it. This is our aerial photo. We need to be careful about georeferencing. We choose the right picture. Now here, both the maps are of the same place. For example, I'd like to show you this monument. It's the same, right? What you need to do is we need to find at least 5 ground control points of the same place. Pin it in this picture first, and then pin it to the georeferenced topo map, and then we can georeference this aerial photo based on the topo map. So let's start. I'd like to go with this one first. So I'll take a corner, then go to the topo map, around in the middle. Let's find it. Okay, this is the point I chose, this corner. So here we get 1. Into layers, So for the second one, I would like to choose this pond, and I would go somewhere around the corner of the path. So it's around here. Into layers, somewhere around here. Yeah, the one, the corner of the path. Let's zoom to this place. So here are two stadiums, and there's a round structure here. Let's zoom in. I would like to take the center point of the round structure. So uncheck this one. Yeah, it's somehow close. This is the center point. As you can see, there's one stadium, there's another stadium, and there's a center point here. This is the third point I'd like to select. So 1, 2, 3. I'll go for the fourth one around this corner. It seems to be another lake. Let's choose this one. Unhide this one. Okay, that's the corner point. 4. Now I want the last one. Here's the place. Okay, a curve and an intersection. It's somewhere around here in the middle. Okay, we have completed our 5 points. Zoom to layers. Let's check our link table. So we have the residuals and the forward. Total RMS error is 3 plus, more than 3. It's okay, not bad. Just as previously done, we will update the display and then we will save it, rectify it. I already have the output folder and I just need to rename it. I will rename it as the same name but rectified. Okay, it's been saved. Now let's bring the rectified folder. I don't see the rectified one. I need to refresh it. There it is. Drag it. Since I already have the rectified one, I don't need the older one, so I'll just remove it. I'll remove the topo map as well. So to create a new vector layer, let's go to output, right click, new, save file. So we will first go for a polygon and then let's give it a name, lake. So the description is unknown coordinate system. We will edit it. We will get our favorite one. Okay. Now, right click here, editor, start editing, then create features, select the lake. We are choosing a polygon, and now let's go to a lake. Now we will select its boundaries so that we can calculate its area and perimeter. Double click. So after we've done editing, we'll go to save edits and we'll go to stop edits. Let's close it. Now we have this lake. Let's calculate its area and perimeter. So first we have to go to here, open attribute table, add field. Let's calculate area. Load. Okay. Right click, calculate geometry. So this is area and I'd like to calculate it in square meters. So we can choose any unit among all these square meters. Okay. I would also like to add perimeter, add field, Perimeter. Load. Okay. Calculate geometry. Perimeter. Meters. That's good. Okay. So we've got the area and we've got the perimeter. Let's find arc toolbox. Then data management tools, features, and inside features we will find feature to point. Double click it. So here we get it, and then we input our value as lake, and then choose our output value. So output folder, so I'd like to choose the one output, click feature as. Okay, let's check, refresh. Here we have it, lake feature class. We can bring it here. So now let's close it all. Zoom to layer. Earlier what we did is we made a polygon from a lake. Now we need to make a polyline. In this case, let us choose a road. Let's make a polyline from this point along the road till here. So let's follow the similar procedure. Catalog, go to output, right click, new, save file. Here it's polyline, so we give the name road. Don't forget to give the projection. Okay, and then editor, start editing, create features. Now we are working on the road, so road. So let's begin marking. Starting point, try your best to go along the road to get the accuracy. Double click. Yeah, it's done. Now we have to save the edits. We need to stop the edits. Now we need to calculate the length of the road. Let's check. Attribute table, add field, length, load. Okay, calculate geometry, length. Let's calculate in kilometers. Let's see. So it's 1.37 kilometers. Let's check again in meters. Okay, it's in meters. So that's right, 1379.92 meters.